Welcome to the next lecture, QPSK. QPSK stands for the quarterly phase shift keying or quarterly phase shift keying. So the QPSK name itself showing defining it is an M array encoding scheme where M is equal to 4. Hence the name quantary meaning is the 4. In the modulator, each digit code generates one of the 4 possible out phases. They are the 45 degrees, 135 degrees, minus 45 degrees and minus 135 degrees. So the mathematically the QPSK signal is represented by like this. It is a 1 bit at t at digit 1 we can represent a 2 et by root of 2 eb by tb cos 2 pi fct plus 2i minus 1 by pi by 4, where t is in between 0 to 2b, where I is equal to 1, 2, 3, 4. I is the stands for the phase. So it is the square root only applicable to the 2 eb by tb only. So the S of t can be represented for I is equal to 1, 2, 3, 4. So it is I is equal to 1 stands for the A cos 2 pi fctb pi by 4, that is 45 degrees. Similarly, I is equal to 2 we are represented as A cos 2 pi fct plus 3 pi by 4. Similarly, minus 3 by 4 and minus pi by 4. Resembling the M is equal to 4. So QPSK modulator, it is defined in the block diagram like this. So the binary data stream is applied to the non-return to 0 level here. So it is the NZ level, and then this is converting the series. This is what the binary stream is nothing but it is serial form, so that we are converting the parallel form, and this parallel form we are directly applying to the 2 modulators. It is nothing but a multiplications of the quadrature oscillators, 2 oscillators. One is the root 2 by root 2t, the cos 2 pi fct. It is the in phase, and sine 2 pi fct is what we are called a quadrature phase. So it is you can represent it is the quadrature phase can be obtained by using the 90 degree phase shift of the cos 2 pi fct. So it is an oscillator, it is an in phase and quadrature component here. So this in phase component and this serial to parallel conversion, this is A1t, say for example we are multiplying with these 2 and then we are adding here. Similarly this also. So it is a in phase component and is a quadrature phase components combinedly we are calling as a QPSK signal. Similarly, at the receiver side, opposite process here, again the same oscillator we are defining here, it is again the cos 2 pi fct and again 90 degrees phase shift we are going to get the sine 2 pi fct, and whatever the signal we are receiving simply multiplying with these oscillators both in the in phase and quadrature components. Then the low pass filters we are going to get 2 low pass filters, and then the addition device. So addition device already you know with based on threshold level is greater than it is a 1, otherwise 0. Like this we are defining both 2 thresholds. So and then these 2 we are adding to the, so that again after adding we are going to convert back to the parallel to series of conversion, so that we are going to get the recovery of the message signal in the binary form. This is the briefly outline of the QPSK receiver. Constellation diagram of the all the 3 ASK, BPSK and QPSK. So we have defined here it is like this. So ASK or on off keying, it is only either on or off. So off, on is 1, off is 0, so that it stands for the red dot defining the off 1. So this is what you call a constellation diagram of the ASK. Similarly, BPSK, it is opposite, 180 degrees phase shift is there, so that it is a 1 and minus 0 stands for the 180 degrees phase shift, so opposite this one. Similarly, QPSK, there are 4 degrees are 45 and 135 is positive and negative, so that it is a 45 degrees, okay, it is a 135, again combinedly if you take it is a minus 45 and minus 135. So it is a quadrature phase shift keying constellation diagrams. So again the quiz test for the QPSK. What is the define the possible output phase in the QPSK? as already previously given as answer is so answer is 45 degrees, 135 degrees, minus 45 degrees and minus 135 degrees.